Okay, another example, example 3 here, we're going to prove that tan theta is always equal to sine theta plus sine squared theta all over cos theta plus sine theta times cos theta. So this one's enormous, and we're going to try to simplify this so that the left side is the same as the right-hand side. But remember, it's just like a puzzle. We're trying to make one of them look like the other. So we're going to first start, and whenever it says prove, I'm starting by separating my left-hand side of the equal sign, which is tan theta, and my right-hand side of the equal sign, which is this whole big thing. Okay, so there's lots of different places you could start here. You could start with the left-hand side. We know that we can replace tan theta with sine over cos. Or you could start over here on the right-hand side and try to do some stuff there to simplify. The neat thing about trig identities, I know you guys think I'm a huge nerd, and I am, but the neat thing about trig identities is that it's a puzzle, and that doesn't mean that you're going to do it in the same way as your neighbor. Some people are going to find a simpler way to get there, and they're going to get there faster, and some people are going to meander through just changing how it looks a bunch of times until they finally get there, and that's okay. The neat thing is you can just keep changing, right? But try not to break any rules, any math rules. So I'm going to start with the right-hand side here. This is a tricky one because this is a new strategy that we're going to use. We're going to use our favorite F word. We're going to use factoring to simplify the right-hand side here. When I look at the right-hand side, I have something plus that same thing squared. So another way for me to write something plus that same something squared is like this, right? Here, my sine theta, I'm just going to replace it with an x for a second. And my sine squared theta, I'm just going to replace that with an x squared for a second. Now, I know how to factor this because there's a common factor of x. So if I were to factor this, it would become x, and then inside the bracket, if I divide both of the original things by x, I'm left with 1 plus x. I'm going to use that same kind of factoring up here. I'm going to come back and erase this in a second because I don't want it in my way. But I'm going to do the same thing on the top here. There's a sine theta here plus, and then this is sine theta times sine theta. So I can pull that common factor of sine theta out front and then divide both of these things by sine theta. Sine theta divided by sine theta will equal 1 plus sine squared theta divided by sine theta will leave me with a sine theta. That's just the same as what I did down here, okay? And then we're going to put that over. We're going to figure out how can I factor that bottom thing. Now this time I've got cos theta plus sine theta times cos theta. You might be thinking, okay, well, I'm using x for sine theta, so cos theta maybe is like a y. So cos theta is y plus sine theta, we were using an x, times cos theta, we were using a y. So this denominator looks like something plus something else times the original something, or y plus x times y. And I know how to factor that one as well. I see that there's a common factor of y here. I can pull the y out front, and I'm left with 1 plus x in the bracket. So I'm going to do the same thing here. I notice that there's a cos x in both of my terms. It's a common factor that I can pull out front. And then I'm going to divide both of these original terms by cos theta. So cos theta divided by cos theta is equal to 1, plus, if I take sine theta cos theta and divide out the cos theta, I'm just going to be left with the sine theta. Okay, now that I have the top and the bottom factored, I can cancel common factors. So out front, I've got sine theta and cos theta. Those are not the same thing, right? This is the opposite over the hypotenuse, and this is the adjacent over the hypotenuse. Not the same. But inside the brackets, everything matches. So I can cancel the entire bracket because I'm multiplying by that bracket on the top and the bottom. And what I'm left with over here is sine theta over cos theta. Don't forget, keep checking with the other side. Over here on the other side, I've got a tan theta. I'm trying to make these things look the same. So I could, underneath tan theta here, I can make it look like sine theta over cos theta using my identity. Or I can use my identity backwards over here on the right-hand side. I can say, oh, I know sine theta over cos theta. That's the same as tan theta. And so don't forget, somebody else might have gone over here and written sine over cos, and theirs is exactly the same, exactly just as right as my solution is, okay? We can write it in different ways. So therefore, we figured out that the left-hand side equals the right-hand side, and that tells me that tan theta is equal to sine theta plus sine squared theta all over cos theta plus sine times cos. Except, so this is true for all theta, except we do have some restrictions here. So when I state my restrictions, I'm looking at that denominator that I had. I've got it here, or I'm going to take a look at it after I factored it. This always makes my life a little bit easier. When I look at these factors, I know that either the first factor can't equal 0 or the second factor equals 0. So I can say that the first factor can't equal 0 and the second factor can't equal 0. So if 1 plus sine theta equaled 0, that would mean that sine theta is negative 1. So we can't have sine theta equal to negative 1. That won't do. And so there we've proven it, and we've got our restrictions. One more type of factoring that I'd like to take a look. So this might show up in the middle of an identity. Here it's just the expression, so we don't have to worry about the whole identity. Don't forget, like before, whenever I'm trying to factor something, because factoring is one of my strategies to change how something looks, whenever I'm factoring something, I can pretend that cos theta is y. So I'm going to do this solution in two different ways. One is a bit slower than the other. So I'm going to do the slower one over here in green, and then I'll do the faster one on the other side in blue. So when you're first getting started, you're not quite used to seeing all of this stuff here. Sometimes what we can do is get rid of those cos thetas just to make our life a little bit easier. I'm going to let all of cos theta be equal to y, just like I used before. So now I can rewrite this expression. This then becomes, instead of cos theta all being squared, I'm going to use y all being squared. And instead of adding cos theta, I'm going to add y. And then I've got the minus 2 at the end. And if you don't like the y's, you can use x's, it doesn't matter. Now when I look at this, it's a lot easier to factor. This is a simple trinomial because there's a 1 in the front. So hopefully you remember how to factor simple trinomials. You ask yourself what multiplies to the last number and what adds to the middle coefficient. So I want to multiply to negative 2 and add to 1. So you'll go through your different options that multiply to negative 2, and you're going to see that the first one here adds up to positive 1. Don't forget that for simple trinomials, I can just go right to brackets with y's in the front, because y times y will give me back that y squared, and I pop the numbers into the bracket. Don't overwork yourself and do decomposition here. That's way too much work. Now at the end, though, I do need to change the y's back into cos thetas. So here, I'll change the y back into a cos theta and the y back into a cos theta. Okay, so this is a bit slower because I took the time to change the cos thetas to y's. Once you get really good at your practice, you're going to be able to just see that because I have something squared and then the something over here, that this is just a simple trinomial. And so there is a 1 here. I would do the exact same step of asking myself what multiplies to negative 2 at the end and what adds to the coefficient in front of the cos theta. Well, that coefficient is 1. So I would go through the same list and then I would figure out, oh, it's 2 and negative 1. And remember, just like last time, instead of, I'm just going to recopy it down here, instead of doing decomposition, because there's no coefficient in front of the cos squared, or in front of the whatever squared, I can just open up 2 sets of brackets. And at the front of each bracket, I'm going to use cos theta, because I want cos theta times cos theta is equal to 1. At the back of each bracket, I just use the 2 numbers that I found, plus 2, and minus 1. And I did get the same answer that I got over here. Don't forget that the order of these brackets does not matter. You could have put the cos theta minus 1 first. And that's it for today. You can find your homework on Schoology or Mr. Bromley has it for you.